Today I'm going to make a video of my semester project of micro and embedded systems, in which we have to make a line follower robot by using the 6 IR sensors, and we have also used a voltage sensor to measure the voltage of the circuit, current sensor to measure the current, and we also have to use the SD card to store the path that the line follower will follow, and the LCD to show the measure current, voltage and other commands on the LCD. So basically I'm going to explain how we have made this project and what are the difficulties we face in this project and what are the commands that we used and what other modules that we are going to use in this project for our line following robot. So first of all, the objective of our this project is design an embedded system and firmware for a line following robot that can remember its random path from point A to point B. Upon reaching point B, it should reverse and recall the path to reach back point A in hardware along with simulation and Proteus. So basically this is the problem statement of our line following robot, in which you see that we have to make line follow which can move from point A to point B, and as well as it has to store the path in the SD card, and when it will reach the point B, then it will take the reverse and follow the stored path and again reach to initial point, that is A. So the task in our project is design and build the Rahbar line following robot who must follow a random given path on planet Rosa with black and white surface using infrared sensors using range of sources. Robot must be built using an Atmel controller, and that should follow any black and white line and remember the path from point A to point B. After this, point B will be black colored obstacle that will be randomly placed in path of robot. Upon identifying the obstacle, the robot should reverse back from point B and reach back safely to starting point A. The path from point A to point B should be stored in SD card. There should be a start stop push button using interrupts. There should be encoders integration with the robot wheels. Battery voltage and current status should be shown by any appropriate method, 7 segment or LCD whether it can be. So this is the following picture of our example of our robot, line following robot, and then here is the specifications and requirements of our deliverables, in which we have you must design custom Atmel controller board by yourself for this project. Simulation should be done in Proteus and also design PCB in the same software. Robotic base of any suitable structure can be brought from market. Acrylic with 2 or 4 wheels. No channel base can be used as modules or can be customized and designed by you. It should operate on battery for at least 20 minutes. Macro SD card module must be used to store the path. IR ultrasonic color sensor can be used to detect the red color obstacle. We use the ADC, timers, interrupts, PWM in Rahbar Brain, a report describing your following. So these are the specs and requirements of our project. Now we are going to start how we have made this project step by step. So first of all, we have to explain the components that we are going to use in this project. So let's move to the components part. So here I am going to show you first explain the mechanical design of our project. For this we have used the robot base, in which we use the 4 wheels chassis. For our line following robot, we select the car base that is easily available in market in reasonable price. We use the 4-wheel car chassis with 4 DC motors. Then we combine 2 motors, so we can use the alternate motor driver that can cover the 2 DC motors maximum. That's why we connect the 2 motors, so we can operate from alternate driver the 4 DC motors. Then we make assembly of car chassis with the nuts and bolts available and connect the DC motors with solder wire, so we can connect them with the battery to supply the voltage. And on this we can place our PC board on this chassis by making another portion. Similarly, how we have made this 2 chassis by using the screws and bolts. Similarly, in this way we can also place our PCB on the upper portion of it. We can call it as the third portion of our robot. So on this way PCB will be double taped. We do not going to use the attach the PCB will double tap because it will not be feasible and it will not look good in the robot and it will not make the proper connections in our PCB. That's why we have used the PCB connected with the third portion of the car by using the same screws and bolts, and then our PCB with the board by screw and bolt, so it will stay strongly and look in presentable way and our board will look good. After this we have the electrical design selection, in which we have the component selection that are different sensors, modules, drivers and will. So first of all we have the motor driver LC298 that receives signals from combinational circuit and control the movement of left and right side motors. After this we have the TT gear motors. The type of TT gear motors we are supposed to use in our project is DC, that can be operated on 3 volt to 6 volt. And after this we are going to use the Li-ion battery, 2 pieces INARS 8650 300 mAh. And after this we have the infrared sensors to detect the black line, so we have used the 6 infrared sensors here. After this we have the DC power switch, male and female temper wires. And after that we have the ACS712 current sensor, uses indirect sensing method to calculate the current to sense current linear low offset Hall sensors used in this IC. After this, to measure the voltage, we have used the voltage sensor module. It is a precise low cost sensor for measuring voltage. It is based on the principle of resistive voltage divider design. It can make right terminal connect input voltage and 5 times smaller. Now we will briefly explain one by one these modules. So first of all we have the infrared sensor. You can see that in the pic we have the infrared sensor. The black light shows the receiver and the white LED shows the IR transmitter. And after this we to control the sensitivity of this IR sensor, we have this screw connected by which we can adjust our sensitivity. After this we have the two LEDs, one will be the power LED and one will be the obstacle LED. Whenever the obstacle will be detected, the light will blow up. And after this we have the 3 connections shown, which is the one VCC ground and one will be the output of this sensor. So an array of IR sensor arranged in a straight row pattern is bolted under the front of the robot. It looks at the position of the line below the robot. Distance between two adjacent sensors is about 1.5 cm. We can use any number of sensors. We have low number, then our board movement is not smooth and it may face problems during short term. So in this project we are going to use the 6 IR sensors minimum. And after this we have these following specs of our IR sensors. You can read them if you want to. And after this we have the power supply, in which we use the Li-ion battery. Power supply is a reference to a source of electrical power device or system that supplies electrical or other types of energy to an output load or group of loads is called power supply unit. And after this you can see that we have the DC motors, which is used to for the movement of our tasks. A simple DC motor, you can call it as simplest DC motor we have in our market, and we are going to use this DC motor. So basically a motor is a device that converts any form of energy into mechanical energy or imparts motion. In constructing a robot, motor usually plays an important role by giving movement to the robot. In general, motor operating with the effect of conductor with current and the permanent magnetic field. The conductor with current utility producing magnetic field that will react with the magnetic fields produced by the permanent magnet to make the motor rotate. So after this we have the following specs of our DC motor, in which we have the rated voltage of 3 to 6 volt, and this motor can unloaded speed of 120 rpm and the maximum torque can produce 800 gram centimeter per minute. And after this you can see that we have the L298 motor driver that is used to drive the motors, in which you see that we can control the 2 maximum motors by using the L298. That's why we have the 4 output pins, in which output 1 and output 2 will be the for one motor and output 3 and 4 will be the for the second motor, in which you can see that we have the 4 input pins: input 1, input 2, input 3 and input 4, 2 for the 1 DC motor and 2 for the 2 motor, and 2 enable pins. If we are going to use the PWM, then we can use these enables with the motors. And after this you can see that we have the 12 volt input to operate this L298 motor driver, and the ground and the 5 volt that this motor will give us output of 5 volt. This L298 driver will work on minimum 12 volt. If you will give less than 12 volt to this motor driver, then it will not work properly. So to operate this properly, we have to give this 12 volt minimum to this motor driver. So L298 motor driver is a high power motor driver module for driving DC and step motors. This module consists of L298 motor driver IC and a 78M05 volt regulator. And after this we have the pin configuration that I have already told you in this L298. And then we have the following features and specs of this L298. You must carefully see these specs because they are going to very useful for your future. In which we see that we have the driver chip double H bridge L298, that's why it is named as L298 H bridge module. And then the motor supply maximum voltage 46 volt and motor supply current maximum will be 2 amperes. And then the logic voltage DC driver voltage 5 to 35 volt and driver current will be the 2 amperes. Maximum power it can produce is 25 watt and current sensor for each motor and power LDO. After this you can see that we have the ACS 712 current sensor that we are going to use to measure the current of our circuit. The ACS 712 is a fully integrated Hall effect based linear current sensor with 2.1 kilo variable voltage isolation and integrated low resistance current conductor. Technical terms aside, it is simply put forth as a current sensor that uses conductor to calculate and measure the amount of current applied. The specs of it can measure both AC and DC currents available as 5 amperes, 20 amperes, 30 amperes. Different ranges can be obtained by using these sensors. Provides isolation from the load, 1.2 milliohm internal conductor resistance, and it has a tolerance of about 1 to 5%. And now you can see the pin out configuration of this IR sensor, in which you see that we have the two wire in and wire out. The wire in through current has to be measured, it's connected here, and wire out from out. And VCC input voltage 5 volt for typical applications, and then we have the ground and the output unlock voltage proportional to current. After this we have the voltage sensor to measure the voltage of our circuit. And voltage direction sensor module is a simply and very useful module that uses a potential divider to reduce an input voltage by a factor of 5. This allows us to use the analog input pin of a microcontroller to monitor voltages higher than it is capable of sensing. So in this voltage sensor, the basic principle to calculate the voltage is a voltage divider rule, in which two resistors are connected in series that the values of these resistors are 30 kilo ohms and 7.5 kilo ohms. They are internally attached resistors too, and basically the voltage is measured across this 7.5 kilo ohms by using the voltage divider. And after this you can see the pin out configuration of this voltage sensor module, in which you can see that we have the ground pin and VCC pin, and there are two resistors are connected that will be 30 kilo ohm and 7.5 kilo ohm. And then the two pins S plus and minus. The S shows the signal pins, analog pin connected to analog pin of Arduino, and then the plus is the NC and minus is the ground. And after this we have the following specs of this voltage sensor module. The input voltage of this can be 0 to 25 volt. Voltage detection range can be from 0.0245 to 25 voltage. And analog voltage resolution needs no external components and is easy to use with microcontrollers. So basically these are our some electrical components and modules that we are going to use in our this line following robots, and I have explain you all these components very carefully. So now our next step is to I had explained all the electrical design of our light following reports, in which the modules and sensors include different that we are going to use. Now our next step is to make a code on the Arduino that we are going to upload on the Arduino Mega, and our robot will work on this code. So basically I'm going to explain the code of that we have made. So basically you can see that first of all I have declared the global variables for the IRs and initialize the input pins to this. For IR1 will be the 23, IR2 25, and similarly for IR3, IR4, IR5 and 6 is the 27, 29, 31, 2. And for the interrupt pin sensor to detect the obstacle, the pin 2 will be used. And for the following analog pins, for the following current and voltage sensor, the A0 and A pin will be going to used. And on the LED we are going to use the following pins, that is connected with the RS will be the 6 pin and enable will be the 5, and D4, D5, D6 and D7 the digital output pins of LED are connected with the 33, 35, 37 and 39. And after this we have the following while loop function, in which you see that we have to initialize the LED, and first we have print the 16 cross LCD module and then the hello world on the LCD. This is the initialization function of the LCD, after which we have declared the some global variables for the Vout, Vin, R1 and R2 is for the 30k and 7.5k. for the two resistors used in the voltage divider and the voltage sensor module, and after with the value, average and start time and time steps hold, temporary and RPM. These are all the different variables that we are going to use in our code. After this you can see that we have the void setup function, in which we have declared and we have set the pin modes of for the following IR sensors, and call the LED function, in which you see that we have the CL.begin, and after that we have declared the pin mode for our IRs, which will be the input and which will be the output. So you can see that here the 6 IR sensors will be as the input, so I have declared the pin mode input for this 6 IR sensor, and 4 pins will be used for motors to operate. That's why I have declared the 10, 11, 12 and 13 the following output pins to operate the motors. And after this we have the LCD begin, the 16 pin and 16 cross 2 LCD, that I here the 16, 2, and after this simply we have print the welcome on the LCD by using the print command. And after this we have the pin mode for the interrupt pin, that we are going to use the interrupt pull up, and after this we have the change. After this we have the following interrupt function, in which we are going to calculate the steps. So here I have made the small function of void interrupt. After this we have the void check function, in which we are going to read the IR sensors, which IR sensor will give us the output and which do not give us the outputs. So basically in this void check function we will check the sensors values, which sensor will give us the 1 and which sensor will give us the 0, and these 1 and 0 will depend on the line. Which sensor is on the line, that sensor will give us the 1, otherwise all the other sensor will give us the 0. So void check function gives us the values from the IR sensors, and depends on the values from the sensor we are going to make our decision for our line following. After this you can see that we have the display function, in which simply we are going to show the voltage, current and different values on the LCD. So here you see that we have simply first print the RPM, current in amperes and voltage, and after this we are going to show our RPM of our robot, current of our circuit and voltage of our circuit on the LCD. That's why we have made this display function. After this we have the following car control functions, in which we have make our if-else conditions, depends on the IR sensors values and which function we are going to operate, whether our robot will move forward, it will move right, it will move left, or it will move stop. So depends on these all conditions, if and else if our robot will operate. For example, if digital read IR1 is 1, IR2 is 1, IR3 0, IR4 1 and IR5 is 1, our robot will move forward. And in the else if IR1 is 1, IR2 is 1, IR3 0, IR4 is now 0 and IR5 is 1, now our robot is moved towards right. And if IR1 is 1, IR2 1, IR3 0, IR4 0, and now IR5 is also 0, again our robot will move towards right. Such is the keyword to move the right. Now for the left we use the keyword khabe. If digital read IR1 is 1, IR2 is 0, IR3 is 0, IR4 is 1, and IR5 is 1, now our robot will move towards left. Similarly, there are many conditions to operate our line following robot. You can see all these conditions in our code. These are all the conditions to operate left, right, forward or stop. Else if we have the stop condition, if any of these conditions are not going to operate, then our else condition will follow and our robot will stop. After this we have the loop function, in which we are going to calculate the speed of our robot. The speed will be calculating using the encoders that are attached in the wheels of our robot. And here you can see the float voltage function, in which we are going to calculate the value of our voltage of our circuit. So from these calculations the voltage of our circuit will be calculated and displayed on the LCD. After this we have the following function named current to measure the current of our circuit, and after the calculation from this line our current will be calculated and it will be shown on the LCD. After this you see that we have make the functions for forward, right, left or stop, and simply we can call these functions here in the if else conditions to operate. We are not going to make the functions again and again in this else condition. We just make the functions and call these functions here. So here you can see that we have the forward function first of all, in which we have set the motors pin number 13 and 11 high and pin number 12 and 10 0. And in the right function means Sajjay functions, we have set the pin 13 and pin 10 0 and pin 11 and pin 12 with the speed of 100. We are not here, you see that we do not give the high speed, which will be 2055, but we use the 100 of value of our RPM of our board. And similarly in the left function khabe, you see that we have given the pin 13 and pin 10 high means 100 speed and pin 11 and 12 0. And similarly when to call the stop function, all our pins will be low, so none of the motors will going to rotate. And after this you see that we have make the speed check function to measure the speed of our robot, from which we can calculate the RPM of our tire by using the encoders connected with the wheels. We can measure the RPM value and simply show it on the LCD. So here you see that we have called the millisecond function, that is the internal function that is already made in the Arduino library. We just call this function, and after the calculations from these steps our RPM will be calculated and it will be displayed on the LCD. So it is the total code that we have made for this line following robot. And now after this robot we have to upload this code in the Arduino Mega that we are going to use, and simply after making the connections hardware our line following robot will be completed. So this is our schematic of our line following robot, in which I have connected different connectors, so I can make a PCB for this design. Here you can see that I have connected the different connectors for the Arduino and VCC port. For this connectors for the IR arrays, this is for the 6th array, and this is for the LCD. These are the Arduino connectors, different connectors, and this you can see that I have made this for the voltage and current sensor, and their connections are made very carefully, so there will be no error in the PCB. because it is very difficult to make a hardware PCB my time, so we connected their connections very carefully according to our design. And now I'm going to show you the Proteus PCB layout. Here you can see that I have made the Proteus PCB layout in which you see that different, and we have only 2 jumpers connected. This is our Proteus PCB design of our line following robot. Now I'm going to show you the 3D visualizer of this. Here you can see this 3D visualizer of this our line following robot. The group name is Solar Strikers and all the group members, roll numbers are mentioned in it. So this is our PCB design of our line following robot. I have made the design Proteus. Now we have to make this design hardware on PCB. Now I'm going to show you some PCB pictures hardware that we have made.
ये हमारा लाइन फॉलोअर रोबोट है, हार्डवेयर कंप्लीट हुआ है, जिसमें हमने आप देख सकते हैं हमने ये एरे यूज़ किया है जिसमें 6 IR लगे हुए हैं। वो हम सिंगल यूज़ कर सकते थे, लेकिन उसमें मसला ये आया था कि वहाँ पे जो उसकी कैलिब्रेशन थी वो हर सेंसर की करनी पड़ती थी, जो कि एनवायरनमेंट के हिसाब से लाइट की सेंसिटिविटी के हिसाब से हिल जाती थी। तो फिर हमने ये एरे यूज़ किया IR सेंसर्स की, जो कि ऑलरेडी कैलिब्रेटेड होती है ऑटोमेटिकली, और इनकी कैलिब्रेशन एक फ़िक्स होती है, मूवमेंट हिलती नहीं है मूवमेंट के साथ। तो इसलिए अब हमने ये फिक्स करके लगा दिया IRs की जगह। उसके बाद ये हमारा PCB बोर्ड है, इस पर कनेक्टेड है। इस पर ये हमारा आर्डिनो मेगा कनेक्टेड हुआ है 2560। फिर ये हमारा उसके बाद SD कार्ड है जिसमें हमारा पार्ट स्टोर हो रहा है, जो कि हमारा एक टारगेट था। उसके बाद ये LCD लगी हुई है, इस पर हमारा वोल्टेज करंट जो भी होगा शो होगा, और जो पास लेफ़्ट टर्न राइट टर्न होगा वो इस पर शो होगा। ये उससे कनेक्शन है। ये हमारा जो है करंट सेंसर लगा हुआ है, ये हमारा करंट मुहैया करके देगा, जो कि हमारा ऑल इफेक्ट जो सेंसर है उसकी प्रिंसिपल जो है ऑल इफेक्ट है। उसके बाद हमारे पास सामने ये नीचे आप देख सकते हैं L298 मोटर ड्राइवर लगा हुआ है, जो कि मैक्सिमम 2 मोटर्स तक कंट्रोल कर सकते हैं। तो ये जो हमारा 4 व्हील ड्राइव था, इसके हमने 2 मोटर्स, लेफ़्ट मोटर्स और राइट मोटर्स को आपस में कंबाइन करके सिंगल मोटर एज यूज़ कर रहे हैं, जो कि फिर हमारा L29 के साथ जाके 2 मोटर्स के थ्रू 4 मोटर्स हम कंट्रोल कर रहे हैं। उसके बाद ये हमारा आप देख सकते हैं नीचे इस टायर के साथ जो है इनकोडर लगा हुआ है, जो कि हमें RPM हमारा कैलकुलेट करके देगा मोटर्स का। उसके बाद ये हमारा वोल्टेज सेंसर लगा हुआ है। ये वोल्टेज सेंसर है, बेसिक इसका प्रिंसिपल होता है वोल्टेज डिवाइडर का, जिसमें 30K और 7.5K का रजिस्टर होता है, जिसमें हम 7.5K के अक्रॉस वोल्टेज मेजर करते हैं। तो बेसिकली हमारे लाइन फॉलोअर रोबोट था। इसे अब अगर ऑन करके देखते हैं तो ये ऑन हो गया। इसमें IRs लगे हुए हैं, ये IRs की सेंसिटिविटी है, आप देख सकते हैं। ये LCD लगी हुई है, यहाँ पे सेंसर्स लगे हैं, L298 लगा है।